Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Daniel Amri bin Ahmad Rusli. So today I will talk about source transformation method and superposition theorem. Now we will look at the question.
Now we will look at question September 2013, question 2b. The question is, for the circuit shown in figure question 2b, determine the voltage Vx across 4 ohm resistor using source transformation method. So in this question, we will use source transformation method to determine Vx here. So source transformation in general that we change the source, for example, the voltage source into the current source by using the formula I equals to V over R, or we change from current source to voltage source by using formula V equal to IR. So in this question, first step we will change the source here, that is current source, that we will change it into voltage source. So we will use formula V equal to IR, that is 4 we get from the current source and then 3 is from the resistor, so we got 12 volt. And then we will change the source over here, that is from voltage source to current source, so we use I equal to V over R, so we got 0.8 ampere. And then after we change the source for this circuit, it will look like this. And then you can see that these two components can be combined because they are in series. So 3 ohm plus 3 ohm equals to 6 ohm. And then we can change this part, that is voltage source to current source, like this. So 12 over 6, we got 2 ampere. And then the circuit will become like this. So in this circuit, we can see that most of the components are parallel, so we can combine them. So first we combine the current source, that is 5, 2 and 0.8, we got 0.5 ampere. And then we parallel the resistor when we got 4, 6 and 5. The answer is 1.62 ohm. So the last source transformation will look like this. So I think that we should change this source into voltage source. So we use V equal to IR. We got 0.81 volt. And then it will come in one loop circuit like this. And then we combine this with two resistor, 1.62 and 2 ohm, and we got like this. So we can use VDR to determine the Vx. So the formula is Vx equals to resistor over total resistor multiplied by the voltage source. So we got 0.425 volt for Vx. Now we will move on to the second question, April 2011, question 5D. The question is, calculate the current I shown in figure question 5D by using superposition theorem. So basically, superposition theorem is when in one circuit that have many source, for example voltage source or current source. So in this question it have two sources, and then the superposition theorem is we turn on only one source and then we switch off the rest of the other source. So in first step we will turn on the 20 volt voltage source here and we switch off the 2 ampere current source, and then it will change the circuit and then it will transform become like this. So after we turn on the 20 volt voltage source, so we can see that 1 ohm and 3 ohm we can combine them because they are in series, and then we can parallel this with the other resistor, but I choose to combine this value with this because we don't want to mix up with this value because we want to calculate the I. So 2 parallel with 4, we got 1.33, and then we will use KVL, that is the voltage across the loop is equal to 0. So the loop will follow clockwise. So we will start with negative 20 plus 4 is plus 1.33 is equals to 0. So is we will get 3.75 ampere, and then the circuit will lastly look like this, and then we can use CDR. Then I equals to 1.33 divided by total resistor multiplied by the current source value 3.75. Then we got 0.936 ampere. Then for the second step is we will turn on the 2 ampere current source. So and then we can use the mesh. So in this we have special case, that is the current source is located between 2 loops, the second loop and the third loop, and then we can use the super mesh. So 1 plus I2 minus I1 because it located between them, plus 4 I3 plus 3 I3 minus I1 equals to 0. And then we will get the equation like this, and we'll continue with the super mesh equation so that we know the value for the 2 ampere at the current source. So 2 equals to I2 minus I3 because of the direction of the current source. So and then we'll got I2 equals to I3 plus 2, and then we will substitute in here the I2, and then we will got I1 negative 4 plus I3 8 equals to negative 2. And then we will calculate KVL at loop 1. So 2 at I1 plus 1 I1 minus I2, and then 3 I1 minus I3 equals to 0. And then also we will substitute the I2 with I3 plus 2. And then we will got I1 6 plus I3 negative 4 equals to 2. After that, we will apply Cramer's rule. First, we will calculate the delta, and then we got negative 32. And then we got for the I1, we got negative 8, and I3 equals to 4. And then we will calculate the value of I1, and that is delta I1 over delta. So we will got 0.25 ampere, I3 negative 0.125 ampere, and then I2 we will substitute the value of I3 here plus 2. Then we got 1.875 ampere. So to calculate the value I over here, that is located between I1 and I3. So I1 minus I3, and then we got 0.375 ampere. So the total of I using superposition theorem is 0.375 plus 0.936 is equal to 1.311 ampere.
And that is one of the example the use of source transformation method and superposition theorem. That's all for this video. Thank you for watching.